one of them I recorded how far they go with 10 gallons of gas. I recorded. Then on this side, I have randomly picked up, or I picked up another 100 cars, different than the other ones, 2 different samples. I emptied the tanks, and I put 10 gallons of regular unleaded gasoline in them, and see how far each one of them they go. They go up to the point that they stop, they cannot go, and I recorded each one of them. So here I have here on screen, this car used regular gasoline, went for 110 miles. Here are the cars that they went, 99 cars in here. How far each one of them they went. This is my raw data. And in here I have another 100 cars. As I said, you usually do not end up with exact number of sample sizes. But anyway, this car, we used 10 gallons of super clean gasoline. We went for 214 and so forth. So notice that in one column I have type of gasoline, in the other one I have mileage. I like to show you examples from different areas. This is the same. Whether you're biologists, you're chemists, you are physicists, you are political scientists, you are economists, it's the same thing. You remember the example I gave you about the psychology mother-daughter relationship? Same thing with the medication. I used to teach these things in medical professions. Those who want to do research in medical. All the same. Gasoline, I don't know, fertilizer. The statistic is the same. Okay, here I have 2 groups of cars, or 2 gasolines, excuse me. And here's the performance. I do an independent t-test. Analyze, compare, means, independent t-test. The variable that has the numbers comes up in here. Hold a second. 1 second. I've coded them one. And then type of gasoline comes down in here. Define group gasoline 1 versus gasoline 2. Okay, and here we are. So we have 100 cars that receive regular gasoline, 100 cars clean gasoline. Here are the average mileages. The regular gas went for, with 10 gallons of oil, went for 100 and let's say 67 miles. The other one went for 218 miles. We want to know whether the difference in here is significant. What do you all think? Go to the top row or bottom row?
Top.
So we look at this number. It's less than 5%. Actually, it is less than 1 in 1,000 actually. We reject the null hypothesis and we conclude that, this one went more than the other one, so and that difference is significant. So super clean gasoline performs significantly better than regular gasoline. Correct? We write the conclusion this way. Let me see. Is 198. 198 is going to be visible. Remember, we're looking at the top row. P is minus 14.693, comma P less than 0.001. This one is better. Okay. Are you with me so far? So you're writing your ARP. You did that. You come to your oral exam, and I'm sitting there, and you're defending. You have done it correctly. You have interpreted correctly. And me being such a mean person, I failed you. That's wrong. And my objection is that what makes you think that the difference that you have found between the performances is because of the quality of the gasoline. The other day when you were testing your car, I was looking through the window, I noticed that these cars that you put super clean gas in, most of them seem to me small Japanese cars, efficient small Japanese, and I looked at through the window, those cars seem to be more American gas guzzlers, 8 cylinders, 6 cylinders. That's why you got better performance in here, because these are Japanese 4-cylinders are in sample are mostly gas guzzlers. You know what? I was looking through the window. I noticed that this set of cars on this side, they tend to be newer cars, most of them. These cars are most of them are vintage cars. You know, that's why you got a difference in here, not because of gasoline.
I think you're looking through the wrong window.
It could be, yeah, or wrong glasses. That day my glasses were not clean. You know, I was looking at these cars, and most of the tires of these cars are pumped up. These are more deflated, more friction. I think that's why you got the difference. You know, give me a chance, I'm gonna also to the excuses tell you that, look, your samples were different. That's why you got two different performances. It had nothing to do with gasoline. It is wrong for you to say that gasoline A is better than gasoline B. It's just the samples are. And in real life, this is often happen that the two populations that you have picked up are different. Like the group of kids that we picked up for our experimental group might be different than the ones that we picked up for control group. That's why at the very beginning of the year, I want to do a test to establish the fact that they are both the same. They are not different. Not the same number of female and male in both groups. This basic self-esteem in both sides are the same. I want to establish the fact that my two samples are equivalent. If you do this and come to oral exam, you will fail. Because objections can be raised. Well, I found difference. What makes you think that the difference is because of the gasoline, might be because of some extraneous variables? So that's the problem. There's an easy way, there's a better way to get around it. And that is that you do pair t-test. Very simple alternative method. Pair t-test. And look at it this way. Why should I pick up 200 cars expensive and still run into this problem? Why don't I just pick up one set of cars? Let's say 100 cars. I'm still trying to compare two groups. I'm still trying to compare two gasolines or two management, well, not management, two medications or whatever. I pick up car number 1. This is here is the car number 0001. This is car. I empty the tank of this first car. This is Chevy 98. Empty the tank with 10 gallons of clean gasoline. I see how far it goes. Goes up to it stops. It goes for 205 miles. When it stops, that means that the tank is empty. Now I put 10 gallons of the regular gasoline in the same car, same driver, same same tire pressure, same vintage. It's the same car. I put 10 gallons of regular gasoline. See how far it goes. It goes for 129 miles. Notice that it is the same car that receives both treatments. Now I cannot argue that they are different cars. I pick up the second car. This is Toyota 2005. Goes for 391 miles with regular, say 261 miles. And I do that for all of my 100 cars. in here, if you do it this way, then all of those extraneous variables, elements of tire size, vintage, and 6-cylinder, 4-cylinder, this and that, you're controlling for those. This t-test is by far better than the other one, independent t-test. With independent t-test, you run into all sorts of objections. With this one, you're controlling for unwanted elements that may creep into your findings and contaminate your results. This is by far better. The good news is that doing it this way, pair t-test, not only is better, it's a lot easier. It's easier to do it, easier to interpret it. Remember, this one was a little convoluted. You have to decide to go to the top row or the bottom row. And sometimes you say the degree of freedom looks very ugly. The other one, basically, you are going to end up doing one sample t-test that you have already there. Let me tell you what I'm talking about. So we don't want to do the pair t-test in this example. Let me close some of my files. Here I want to here I picked up 100 cars. Sample size is smaller. I save some money. Now, if you can pick up 200, that's even better. Notice that in here, for each car, I have two corresponding values in here. Each individual has received both treatments. Placebo the first week, and then I measure the blood pressure, and then I give them the real medication next week. Or these are ideal for pre-test, post-test. In September, I measure the self-esteem of the kids. The same kid, I measured his self-esteem at the end of the year. I'll see whether the difference is important, is significant. Anyway, are you with me? The way that the data is, how the data is recorded. Notice that the data is recorded differently. In here you have two columns, both of them are numbers. One is pre, one is post, or one is drug A, one is drug B, or gasoline A, gasoline B. Each individual in here, or each case, has two corresponding values. I want to do a paired t-test. I'm pairing them. There are two ways you can do it. The first way that is intuitive, and that's the way that I learned to do it when I was at school, is intuitive, but don't do it this way because you are going to end up with several extra clicks. SPSS has now come up with this much faster way to do it. So I'm going to do it the long way. So don't write it down, you're not going to do this the long way. Now here is Chevy 98, remember? When 356 miles with the new gasoline, 234 miles with the old one, you can subtract the difference, you can find the difference. This number minus difference, put it in here, and that you are not going to do that, by the way. The number that you put the difference in here is the difference in performance between before and after, or gasoline A, gasoline. And do that for every one of them. Find the difference in this column. Let me do it. You're not going to do that. Let me get the difference between clean gasoline and old gasoline. Transform, compute. Here we call it, let's call it difference. And here I put the super clean gasoline minus the gasoline. And, okay. Here we are. So I found the differences in here. This is the impact. This is the difference. So for Chevy, our first car, Chevy 98, that car went 122 miles more with the clean gasoline. And the second one was Toyota 2005. It went 37 miles better with clean gasoline. So these are the improvement, let's call it. Now, oh, by the way, what is the null hypothesis in here?
No effect.
The null hypothesis, there is no difference between the gasolines, huh? The difference is zero. If the difference is zero, if in reality, really there is no difference between the two gasoline. One of them has food coloring in it, it looks different, but they're really the same. If that is the case, what do you expect to see in this color? If both of them are the same, zero or around zero, there might be a few drops of oil left in the pipe, whatever. This number should be around zero, give and take. But the average of this column should be zero, huh? Around zero, give and take. So I want to know whether the average of this column is significantly different than zero. Analyze, compare means, one sample details. We are not going to do that, guys. This is too many clicks in here. Put this difference in here. I want to know whether this column is significantly different than zero. Put zero in here. Click OK. Here we are.
So these steps that you're just showing us, you're saying we're not going to be doing
No,
this?
you're not going to do that.
Yeah, I'm not writing anything from them.
Intuitively, it makes sense, huh? I want to know whether the improvement is significantly different than zero. I do one sample details. So the difference, the average difference is, so the average of that column difference is, or let's call it average improvement, is 54 miles for 10 gallons of oil. Is that significant? Yeah, it is significant. So gasoline, super clean gasoline performs significantly better than the old gasoline. It's significant. The difference, look at this difference. This is not zero, or around zero. But you're not going to do it this way. Forget about this column. So here I have tested two gasolines on the same cars. Instead of going through compute and all those things, go to analyze, compare. This is the way you are going to do it. Compare means, paired samples. You bring one of the variables first, and then the second one next. Or select both of them and then bring them out. That's it. Click OK. Here we are. We have 120 cars all together. Remember, it's not 240 cars. It's 120 cars. When we fed them super clean gasoline, on average, cars, they went for 294 miles. When the same 120 cars, when we gave them regular gasoline, they, on average, they went for 240 miles. So it broke it down into both of the cars. And the difference in here, well, you remember this number? This is the difference between performances. This is the way that we did it earlier. Mean difference. So we want to know whether this 54 miles difference in performances is significant or not. What do you think?
Yes.
It is significant. Oh, let's look at the other one. The difference is the same thing. Oh, look at the t-values. 12.601, 119. How about the other one? 12.601, 119. It's the same thing. So instead of doing independent sample t-test, here you prefer to do pair t-test because now you have control for all those extraneous elements that may contaminate your results. Simple to do, but basically this is a one sample t-test you are doing. You do one sample t-test on the improvement, the difference between the ideal test for all those occasions that you're doing pre-test and post-test. The same individual do pre-test, post-test. Or the same school campus. TOS score last year, TOS score today. See whether that school has improved.
So that's pair t-test, pre-test, post-test.
The pre-test, post-test are excellent example for what you want to do pair t-test. Let's see. Let me see if I have more examples.
Dr. Sajjad,
Yes.
when would you use a independent t-test versus paired t-test?
I was going to talk about actually. There are times when you want to do t-test, you need to ask yourself, can I? Let me step back. You all agree that paired t-test is better than independent t-test. You all agree with that? So you look at the problem. The question you should ask yourself is that, oh, paired t-test is better than independent t-test. Can I do paired t-test in here? If you can do it, you need to do paired t-test, not independent. But there are times that you say, can I do paired t-test? No.
So how do you know that? How do you know you can do a paired?
Well, you need to make judgment. Let me give you a couple of examples. I want to know whether the vocabulary and the number of words that men have is different than the number of words that women have. Can I do pair t-test? Can I pick up a man or a female, see how many words she has, and then do an operation on her, change her to a man, and then ask?
Well, isn't there multiple pairs that you can do in the pair t-test? So couldn't we do like female words, male words? Is it a way to?
That's independent t-test.
Oh, that would be independent. But there's no way we can do that in the pair because I noticed that when
There's
we were
no,
adding there was.
because pair t-test is that you have one individual with two numbers. In the example of words, I'm stuck. I cannot do pair t-test. But with the gasoline, yeah, I can pick up, put both gasolines in the same car. Self-esteem, for example, another example. Remember the one that you just did, I cannot remember if you did it or not. But I can compare the self-esteem of experimental group versus control group. I'm stuck to independent t-test. But I can do, for example, pair t-test, self-esteem is September of Jorge, and the same self-esteem of same individual at the end of the year. For each individual, I have pre-test, post-test, pre-test, post-test. That's pair.
Because the one you sent out was before and after, so we can use that one.
Yeah, that self-esteem is when I measured in reality, by the way, we did that. We measure the self-esteem of students at the beginning of the year, and then self-esteem of students at the end of the year. We wanted to know whether there has been improvement from this 1 year of treatment. a year of treatment has been effective or not. I'm sorry, James, go ahead.
No, how do you write it so you know it's not, if you're both looking, do you write it the same, similar way?
The same, this will not change, except in your conclusion when you write, it's a good idea to mention that what kind of test you have done. That we did a pair t-test and the result is this and that.
So whether it's independent, pair,
You want to mention that in your conclusion.
even if it's a one sample?
Yeah, even if it is one sample, yeah. Here I have the example of before and after. We measure the self-esteem of students in September, and then in June, we measure the self-esteem of the same student. So here is, let's say, Ignacio. His self-esteem was 12 at the beginning of the year. After we gave him 1 year of treatment, his self-esteem jumped to 19. Here's Consuelo. 25 was the self-esteem before, 26 at the end of the year. Notice that these two numbers refer to the same individual. Analyze, compare means, paired samples t-test. We bring these two, let me see if I can select both of them. Yeah, I can. Bring them in here.
I have a question before you exit out of here. How number 2 dropped down for pair 2, how would we, is it possible that, like, in what cases would we have a second pair? If that makes sense.
You mean to put in this second row?
Yeah, like what is that for? Why did that?
The reason is that there are times that you want to do a bunch of pair t-tests. You see, this window is very large. It's like independent t-tests, you know, that with one shot you got several t-tests. And here sometimes you want to compare the self-esteem before and after, then you want to compare the weight before and after, and then you want to compare their height before and after. Yeah. When one shot you bring all of them in here in pairs, you bring them over. And you do that. Okay, so we want to look at the self-esteem before and after. Here we are. 60 students are in our experiment. Do not add up these two numbers. There are not 120 students, there are 60 students in our experiment. Our N is 60. And these 60 students, we on average their self-esteem before, let's say in September was 19.73, and then the same 60 students, when after 1 year of treatment, their average self-esteem was 24.06. We want to know whether this difference in here, the difference in self-esteem before and after, which represents what? The treatment effect. We want to know whether that treatment effect, which is, by the way, is 4.333, that treatment effect is significant or not. What do you all think?
Yes.
It is significant. Did it drop or did it go up? Look at this. Self-esteem was 19 before and has jumped to 24 now, and that difference is significant. So the treatment was effective in improving the self-esteem of 10-year-old students.
Why is the degrees of freedom 59 instead of
So
58?
basically here you are doing one sample t-test, and you have one sample only. One sample of cards, 100 cards.
Oh, got
But
it.
each of them has received both treatments. So in here we have only 60 students. So our degrees of freedom is n minus 1. You don't have two samples, two separate samples. No, it's a one sample. Except each one has received 2 treatments. Because sample size is 60, so degrees of freedom is 60 minus 1. I'm sorry, that. Go.
Do we need to look at the correlation value for anything?
This middle one, forget about this middle table. I'll get to these kind of things later on, the issue of correlation.
Yeah, but if you put so when you bring over your variables, when you're doing this test, if you change which variable is first,
It doesn't matter.
But
Let's do it. No.
because the mean is -4,
No,
but
the
when,
place, the place
Yeah.
of these two lines will switch,
yeah,
and then instead of this one minus this one, it becomes this one minus this one. So really, this negative will not make any sense. I can see exactly what you are saying.
okay.
This negative doesn't. Just look at these two numbers to see which one of them is more, which one of them is less. When
Okay.
you want to interpret the result, I know that at the end of the year, self-esteem was more than the beginning of the year.
So then in the conclusion, we could have different, like, it'll either be negative t-value or positive, right?
Yeah, it can be, depending which one of them is
Yeah.
applicable to the other one. So this is irrelevant, this negative or positive. You need to know this one, whether at the end of the year was more or less. And that's a good question. Many years ago, City of Austin for several years, for many years, contracted with us. And we did citizen survey for City of Austin massive. And in every one of them, we did come to we divided the City of Austin into 7 regions. And we did all sorts of comparison among the regions. In every one of them, in the reports that we wrote for several years, we found that people in East Austin had a very negative view of police. Which, let's suppose that, and I have made this one based on that experiment we have. So let's say that the police department know that they have a very negative image in East Austin, and they want to improve it. One of the smart guys in one of the meetings in the police department raised his hand and said, "Boss, excuse me, chief, why don't we come up with this TV commercial to show how helpful policemen they are?" I say in commercial showing the policeman holding the hand of this old lady crossing the street, giving chocolates to the kids, playing basketball in the evenings with the kids. He said, police does good things and all. Chief said, I know that's a good idea, we need to do that. But is that going to be effective or not? We don't know, and TV commercials are very expensive. Just out of curiosity, guys, you know how much was 30 seconds of TV commercial for Super Bowl? Not last time, I did not say, but the one that was in Santa Clara. 30 seconds, one shot. How much?
30 million?
No, it was $5 million for 30 seconds. 5 million. One shot, one time. TV commercials are expensive. So the chief said, why don't we test drive it? Why don't we test to see whether it's effective or not? Why don't we make a commercial and check to see if it's effective? If it's not effective, let's not waste on it. So they come out and they hire this company and come out with 30-second commercial. And to test drive it, they go to East Austin, to one of the highest schools. And let's say the officer is in a plain clothes, so it does not have any impact on the kids. And gives them a questionnaire about what do you think of the police department, how terrible they are, how wonderful they are. Students say, right, and then the police guy said, oh, okay guys, I wanted to show you guys this clip. And he shows them the clip that how police is helping people, and then at the end, pass on similar questions. And now, what do you think of the police? And then students, the same students, they give grade. So here I have, for each student, I have 2 scores. before watching the commercial, after watching the commercial. You can use this for focus group. They do that. Businesses, they do that focus group. So you're with me. I have before and after. I want to know whether the clip is effective or not. Analyze, compare means, pairs. I have done it so many times. Why don't you just go in here, huh? You select these. It doesn't matter which one first, which one second. You look at the numbers to see the direction of difference. Click OK. There are 100 students in the experiment. So degrees of freedom is 99. So before watching the commercial, the attitude was 57.90. Let's suppose that the higher the number, the more positive they are. But after watching the clip, the view was about 76. We want to know whether this difference right here, which is 18 points, whether this 18 points is significant or not. What do you all think?
Yeah.
It's significant. So by looking at this, you can say that the commercial significantly improves the attitude of students toward police department or police officers. You look at these two to tell the direction of the difference. It was improvement, correct? Please.
So if you were to say like a teacher decides to look at the students' test scores prior to them teaching this and then after teaching them that, and then looking at their test scores, if they've improved, if there is a significant change, then they could say that method of teaching those students got them higher test scores. Or not.
Maybe. Okay. I said that peer t-test is better than independent t-test, correct? I want to use the same example that Jenna mentioned. This one, so you look at your problem and say that, can I do peer t-test? Yes, okay, do peer t-test. If the answer is no, then settle for something less independent t-test. So I want to give you an example, see what you think about it. Here's my example. I have come up with two methods of teaching, let's say 10-year-old mathematics. Computer interactive versus old-fashioned blackboard with paper and pen. So I want to know which of these two methods are best. Which t-test do I need to use? Independent or pair t-test?
Independent.
Independent.
Why? You know, we're not a pair t-test is better.
Because you can't take one student, teach him both ways and understand which one he learned from.
Yeah, so if we teach them the first one, let's say interactive one, and then wait for 1 year to teach them that at the end of the year,
He already knew it.
I mean, there's a, yeah.
Not starting at the same point.
There's a carryover in here. After all, he is 1 year older, huh? Can we do pair t-test, guys? You all agree that you cannot do pair t-test? Because the difference between first test and second test, there might be some carryover. So you all agree that you cannot do pair t-test? Is there a unanimous agreement? Remember guys, I believe in democracy. Majority is always right.
I agree.
Agree? Everybody agrees?
Can you say the example one more time? I'm sorry, just really quick. I don't think
I have two methods of teaching
Right, okay.
to 10-year-olds, mathematics.
Right.
I want to know whether I can do pair t-test. Can I pick up the same kid for 1 year teaching the regular method, when he gets 1 year older, teaching the second method, and then compare them?
Oh, I see what you're saying.
Can work that way, huh? 1 year older, more mature, IQ has gone carry over. You all agree that you cannot do pair test, correct?
Yes.
Yes.
You're all wrong.
I feel like that you set us up for that one.
Yeah, I convoluted what Jenna said. But I'm glad that you brought that issue up. We know that pair t-test is best. If you cannot do pair t-test like this one, yeah, you're right, cannot do pair t-test. Can we approximate that? I don't want to do independent t-test.
We can't.
Oh, no.
I don't want to do independent t-test. I should do it this way. Pair t-test is higher level, better. I don't want to do independent t-test. I know that's inferior. Can I get a little bit closer to this one, at least approximate that? You ask yourself. And if it is possible to approximate this one, yes, you should do it this way. So in this particular case, that's how I'm going to do it. I pick up one 10-year-old boy, Hispanic, middle class, teach him old method, and I will find another 10-year-old boy, Hispanic, middle class, whatever that is relevant that I can match them. Don't match them based on shoe size and hat size. You match them based on relevant, race, gender, socioeconomic status, family structure, parents both are there or one of them there. I match these two, put them next to each other as if these are one person. I am controlling for race, I'm controlling for gender, I'm controlling for socioeconomic status of the family. They're matched together as if they are one person. One person received method A, one person received method B. Then I go to the second person. This one is Margaret, I don't know, Consuelo. Let's say 11-year-old, female, low income, with single mother, I'm matched.
Is this where you would use the different rows when you're doing
Is it
the-
the same? Still I have two scores.
Mhm.
Although they are two different people, I assume that these are the same person. It's the same pair, same match. We call it match. Because I have control now for all relevant things as much as I can. Match based on socioeconomic, gender, race, whatever. Then I move to the second pair, or second match, I should say. And then I move to the next match. So I have, although I have two groups of people, but they are matched together. So when I run a pair t-test in here, I have already control for a lot of things that could have possibly contaminated my results.
So you controlled for those things by selecting similar.
By selection, yeah.
Yeah.
I control. So, you can either do pure pair t-test, like self-esteem before, self-esteem after, or the same car, two gasolines. Or you can approximate it by doing matched pair t-test. I want to know whether husbands, let's say I want to know whether men spend more money on Christmas shopping or women spend more money on Christmas shopping. Men versus women. Independent t-test. Well, why don't we do something better, closer to pair t-test? Why don't I pick up husband and wife? So it's the family that is considered. We're controlling for socioeconomic and possibly race and other things. So how much husband spend, how much wife spend? I don't know, that's a good example. But what I am saying is that if you can do a pure pair t-test, wonderful.
What is it called?
Paired t-test.
I know.
Paired
You
t-test.
said there was pure.
Oh, pure.
Pure.
We just call it pair t-test. You do
Oh.
either pair t-test, okay, before after, or you do matched pair t-test. This is when you are matching people, and you're assuming they are the same.
All right.
did not get chance, I said, I knew that I'm very ambitious for tomorrow. I did not get chance to talk about estimation, which is very important. There was one question, I have 2 minutes. One question that when you reject the null hypothesis, when you say there is a difference, the question that what pops up is that, okay, there is a difference. By how much? By how much the difference is. That's called estimation. Next week, I'm going to go over that and clarify. It's not much time. But we learned one sample t-test, independent t-test, and paired t-test, and its cousin, which is matched pair t-test. Which is really basically, you do the same thing, except you're matching people. Any question? Once, twice, solved, but not solved. Excuse me, Jenna.
The homework, we're adding on to it.
Okay. I'm going to send you homework for independent t-test and paired t-test. I want you to write the conclusion correctly and put it with, what do you call it? Symbolic thing.
So we need to go back for the ones that we did and.
Yeah, put the symbolic as well on every one of them. And then turn them in next week.
Alrighty then.
For new homework or just for the one we
For
are?
all of them.
For the one we
Hang on to this, and you don't need to go to your computer and mess around with it. By hand, you can write down the symbolic to make it faster. I don't want you to spend more time on the
And do the
first test.
When is our next,
Does anybody remember?
I thought you said you were gonna cancel all the tests this semester.
Oh, yeah, that's everybody across the board.
Yeah, that's not.
Well,
you guys
if you
didn't
guys
do
bring
that.
pizza and this has any problems, you can.
I'll get pizza